My name is Brian Smith. First off, thanks to Calvin for kind of extending the platform of this group, because I think he does a great job of hosting and facilitating. If you go to other meetup groups, for instance, you can really tell a difference. So thank you. I'm really pleased to present. So we're going to go through kind of a newer development that's come out of some of the data science world, specifically if you're into signal processing or any kind of data analysis with pandas. What I wanted to do is sort of show a typical workflow that I might utilize, and keep in mind I've only been utilizing Python since 2013, so I consider myself a very aggressive enthusiast, but by no means there's a lot of people I know that have been using it since 2010, and the list goes on. So but with this being kind of a product that's come out, part of the stack with pandas and visualization with data science libraries, I want to just show a really friendly introduction. Especially I know a lot of people are kind of seeing Python for the first time, so this is, I think, had I got to see this first, it would have been really helpful. It would have really helped kind of explain, I don't know, just how you can pass information to other developers, which is not something that there's a lot of books about, But in any case, if you're working in any kind of academic environment, or where you've got a lot of sort of raw data that you're needing to sort of clean up, but you need to show your work, right, so that everybody thinks you're legit. This is a tool that I've found has been very, very helpful, and we'll go through a little bit why that is. So a little bit about me. Again, my name is Brian Smith. I work as part of an agile development team for the Department of Defense. So if anybody knows where Fort Bend is, out near Fort Harrison State Park, that's a huge center, and we've got a big IT shop. And so I'm an agile developer for DoD. We build all kind of applications for soldiers and their families, and so they can track their pay, for instance, whenever they're deployed. So it's a really cool job, and my agency is very primed to use new languages, and they've got this sort of mission statement about agile transformation. So I got sucked up into all that just with some of my time with our legacy environments, and then also things that we've had traditionally in access databases. My company went crazy with access databases. So now that we're sort of moving up the chain in a lot of ways and pulling these guys out of micro environments into actual supported production units, SQL Server has been dominant. We're a .NET team, and where I'm using Python is a couple things. I'm keeping the business analysts happy with giving them sort of their own little data farms from APIs that we're building, and I'm showing them how to sort of do the same reproducible analysis, and they want the visualization stuff. So I mean, Python's really great at that, and we'll go through a couple demonstrations. I really got involved with learning Python whenever I was in grad school with public administration, political science. You do a lot of statistical analysis, looking at variation and things like that. My university was using a lot of SPSS at the time, so if you've ever done modeling with SPSS, that was a tool that I was sort of exposed to early, and then boom, this explosion of a library, I think, grew in terms of the PyPy ranking, and that was the Pandas library. So when Pandas came out, I was yeah, that's my jam. This is awesome. So it took a lot of the stuff that we were doing at an access database level up to something that now I can specifically work with Oracle databases, SQL Server, a lot of these larger units that either you have to be in Java to work through Oracle, or you've got to work .NET and SQL, and it's all C# basically for scripting. So so that whole environment is kind of where I come from. Python is definitely one of my main interests ever since I started learning, just because it's so much fun. I'm a husband and dad when I'm not on my computer, which isn't enough, unfortunately. And then when we're not doing that, I love tailgating. It's the best thing. Okay, so our focus today, I wanted to just give an overview a little bit about Project Jupyter, which if you've seen like some of the emails coming out or been on the web and like kind of seen some demonstrations yourself, like there's a lot of like conference material that has been using Python notebooks for like many years, and then all of a sudden, like without much notice, the project name was encapsulated into something much larger, and that's been Jupyter Notebooks. So it's an application that was built in Python. It is integrated very, very heavily with JavaScript. So like because it's an open source project, for folks that know JavaScript, you could actually work on Jupyter and like build it as a product itself. But it's native to Python, and it's begun to extend itself into many like syntaxes. So if you're working in like R or Ruby or some of these other languages, what's great is a Jupyter Notebook is very like agnostic on the language level. Like we don't have to get into these sort of like cultural wars between like which syntax is better, right? You can really sidestep a lot of this and say, can I reproduce the same thing, you know, on my stack that you did on yours? And when you get to more of like an even playing field, like that's really where I think there's not anything out there that I've seen that rivals what Jupyter's trying to do and where it's already at, like just in a couple of years of development. So we'll go through that. Wow, that was kind of a very passionate agenda speaking item. So now I have to like keep that up. All right, so we'll go through a little bit of like what like projects have like been coming out recently. Like so, if anybody's like a space science nerd, like I'm hoping somebody is. I heard somebody say signal analysis earlier, and I was just like, oh man, this is gonna be like amazing for them. Okay, so we're gonna take a look at that. I've got a repo like for a project that I'll flash at the end here, but what I want to do is kind of do a demo of what you can do with the package that I built. And for anybody that you've never really touched Python before, maybe you played around like with some of the tutorials online, I want to introduce this in a really friendly way. So for folks that have been like, I don't know, programming for a long time in Python, if you feel insulted, please don't. Like, there's a lot of folks that are seeing it for the first time, and we want to like, I don't know, provide them the same excitement that you felt like when it was your first time. Now I'm giving a sex talk. Like this isn't what I planned. Okay, all right. So let's get back to the slides. Somebody just gave me a bow chicka. All right. So Jupyter project. This is, first off, I've got a nice headshot of the guy standing to the right. This dude is a legend in like the Python data analysis sort of like enclave. Like so, if you've seen anything like out of Python or PyData New York or PyData Seattle, Fernando Perez, first off, is sort of the inventor of the IPython notebook, and thus like kind of one of the main folks established to the Jupyter project. He hails from the University of Berkeley, and he's got an amazing like grant organizational system set up through the Berkeley Institute of Data Science, and there's a ton of money that is being sort of like sloshed together between the Python Software Foundation, Continuum Analytics, and Microsoft, Intel, you name it. So there's a lot of development going into this that I think is very important. Like corporations, you know, they put a lot of resources out, but to see this much concentration in to like the Jupyter project, I think is just really important to just know that it's happening. So it's a really it's a nice project. Actually, Ryan Wade and I were both up in Chicago just a couple weeks ago. Like Chicago had a Jupyter day where it was actually open source development on this project itself, and it was really sweet. It was at a place called Civis Analytics, and like it was open office space like this. It was amazing. Anyways, so it's an open source project. It's growing. I would say some of the documentation on it is also growing along, but for anything that I've wanted to find so far specific to like Ruby or R or some of the other languages that are very similar to how Python works, I found those installations to be pretty simple, and I'm on a Windows machine, so like if you're on a Mac, you cannot complain, because like that's all I hear about. Like it's like, oh, it just works on a Mac, and like, yeah, I know, but like my company uses Windows, so I got to like rough it. So if I got it on my Windows machine, like Mac folks, like you, like there is no excuse. But I could still help you, at least point you to the right documentation. So there's a lot of like languages, first off, that are integrated with Jupyter Notebooks, and I can kind of show you some more on that. But the main thing that you need to kind of understand is that we're going to be working through a web browser, and the web browser itself is going to have activated cells that are ready for like a line of syntax that you can do a few things with. First, like if you want to execute like actual code and like see like what it did immediately, like in some other languages you have to like sort of select all the syntax and like hit start and debug and whatever and get things to run. What's nice about this is you can go like step at a time and really build nice clean syntax that you know works because you're testing as you go, and it makes for really rapid prototyping if you're just starting with like messy data, don't know what to do with it. Like this has just been a really, I think, great tool for grabbing something you have no idea what's in that file, but you're going to reach in for the first time and like grab stuff and normalize it. You can also like really make this very presentation friendly, which I've done for the project on our repo. Markdown is a language that's used a lot of times within HTML to like embed certain things like images, HTML code itself, web content, video. I know somebody mentioned that they do a lot of video stuff. So this is like very integrated with that just because Python has a lot of like multimedia support in their ecosystem. But beyond that, there is a very like academic sort of like root in where the Jupyter Notebooks come from. So you've got LaTeX, which does a lot of like the sine, cosine, kind of funky characters that you see anytime you're working with like sort of more abstract math. So those are the three types of cells that you'll see as we work through. This is this is. So has anyone heard? So I was like the worst kept secret, and like I'm like this is like way late. So, but a few months ago, there was like an official release that came out about detection of a project called LIGO, which LIGO was this really, really elaborate laser system that got set up in Seattle and in Louisiana that would measure waves received from outer space, like based on like, and it's like the most like minute, like smallest sensation you can imagine. And so they had these very, very like precise lasers set up in two different locations, and they were able to detect the formation of two black holes like sort of circling together and capture it like using signal analysis. So the results were published in Python. And that's really important. Like, if you're, if you consider yourself like a web developer, not necessarily on the data side, it's really important to understand that the language has been like grown and like strengthened to the degree that like we're detecting gravitational waves in the very same language that like Django and Flask are written. Like, whoa, like that's beyond what Ruby can do. Like, I just hate. At this moment, it doesn't mean that Ruby can't catch up. I'm just saying, like, the Python community has done this, so that's amazing to me. Now, if they want, if we're just doing signal analysis, I'm sure something else could be published. But the actual like scientific document published was an IPython notebook, and it came from multiple sources. And anyways, it's been the thing that like a lot of like data scientist guys have been beating their chest on Twitter and like. Anyway, yeah. So what it essentially did, it was really validate a lot of Einstein's theories about relativity and space-time, and how gravity is a lot like a fabric, and it has ripples, and as things move and collide and form, those ripples are sent out to the rest of the universe. We feel that, we detected it, we proved it. So like now everybody's wanting to put stuff in outer space and like find more gravitational waves. So it's really exciting. So. I don't know if we've got enough time for that, but that's fine. So the language is very strong. What we could do actually is here's my proof in the pudding. All right, so this is a URL specifically to the LIGO experiment, and what I'll do is like zoom in. Pretty sure that's an important thing. And it's not pretty whatsoever, right? It's just like bold text, plain text, like URLs. But I want to pull down like deeper in the document where it's talking about like where to download the data and like where it's coming from. These are all just sort of instructions on how to work with this. I don't anticipate anybody to work with LIGO data. Like I know you like for some people that are showing up to a Python conference to a meetup for the first time, I'm not asking you to prove Einstein like with Python like in the first swig. Like this is just sort of visual. But I want to pull down specifically like down to this part of the page. This is a web page. This is not anything that you wouldn't have access to like even on your smartphone. You'll notice that there is a terminal here that says into, so it's like in and out processing, right? This was something introduced with IPython, which was a command line interface, and it was integrated into a web browser under the IPython notebook. This is really where the whole thing has kind of come and grown from. What I'd like to show you is this right here, which is the Wunderground demo that we all would love to see, which is how do I take information, okay, like, wow, that was loud pop. How do I take information which, for instance, might be in outer space and capture it all and bring it in for analysis and representation, because that might be something that people will find rather handy. So if you've ever been onto like a Wunderground, just finding like local data, this is what you might come across, which is let's see a full forecast, for instance. You'll find like the current temperature. You'll find like what the conditions are. If there's like 10 days of projection that's available, chance of precipitation, highs and lows for a day, for instance. And down here at the bottom, and this is really important for what we're about to do, there is an almanac about like historical data about whichever geographical region that you're using. And there's a code here that is like non-obvious whatsoever that is a city code. So what we're going to do in a minute, I'm going to bring you through like a live session using like a Jupyter Notebook, and we're actually going to go scrape like Wunderground data like off of the web, bring it into like a local source, and then I'm going to like sort of read all that data into a Jupyter Notebook. And you may think, whoa, that's like if you haven't done that before, there's a really like easy method to do that. All you need to do is like download the repo, and we'll get to that in just a minute. Okay, so let's so the first thing I'm going to do, if you're not familiar with like a command line, if like let's say if you have like Anaconda installed or something, you might go out to Launcher and launch this, but I'm going to encourage as much like command line as possible. So if you have like Anaconda installed, let's say, which I recommend, I'm working with Python 3, and the command line that I'm using is just Jupyter Notebook, like wide open, like into the prompt. If you haven't used command line, or if you're not familiar with it, like there is a GUI launcher that Anaconda provides that is going to do the same thing that what you're going to see here. Okay, so you'll notice that like a browser window popped up. Like I'm using Chrome, for instance, which I recommend. Like it seems to work really well. What I've got is like sort of my files, like all laid out like in sort of like where my home is located, which is in like my documents. So if you have like a central spot for your documents, that's essentially what you're seeing here. I'm going to go into the project folder that I specifically built for tonight's demo, and all I'm doing is just clicking through what you would normally do through like a normal directory, and there is a subfolder called PyData Indy-WebScrape-Wunderground. All right, so let's open that up. There's a few files like in this folder that I'd like to point to. The main one we're going to work through is this IPython notebook that's got the IPy NB extension. Can you see that in the back okay, or do I need to a little bit bigger? Is that a little better? Okay. Everybody in the back can kind of see that? Okay, cool. So the main like document we're going to work with is the IPython notebook. So like I'll go ahead and click that, and this opens in like a new window. You'll see a few things like along the top of the Jupyter window that we'll get to in just a moment. But you'll notice that this kind of has a really similar format to some of the characteristics that you saw in the LIGO document, and that's basically because it was a published IPython notebook. What they failed to provide, unfortunately, is like a lot of HTML formatting, like which I think would, is a super easy thing to do. So I'm going to double click first off. This is like an active cell, so what you're seeing is like, like embedded image, embedded text. But if I double click on it, what you get is sort of like this like markdown language that I've already assigned into it. Hitting Shift Enter on any cell will execute it in the notebook. So you can see how like I had code like back behind the markdown block, and then Shift Enter like gives me sort of like clean, presentable, like something I can hand to somebody like with a heading, let's say. So here's a little bit of like a intro about what we're going to run through this Wunderground notebook. It uses a couple of libraries that are core like to like data analysis like in Python, mainly NumPy, Pandas, and Matplotlib. This demo will use all of those. A little bit about our data. First off, like I'm going to walk you through just like the shell directory just so you can see where like files are located, and then we're going to execute a couple of like Python scripts that I've developed, and we can take a moment just to see each one that I've written for you. The first one that we're going to run is like a web scraper. So this is going to be a script that I've already like built for you. You can go out and like kind of like hack around on it and see what it does. But essentially what it does is going to pass like a fixed URL for Wunderground's like domain, and we're going to replace like in an array the day values for like archived weather data, and we're going to scrape like maybe 2 or 3 months for the last for the last period for Indianapolis, let's say. You can easily change city codes with like the script that I wrote, and we'll talk through that in just a minute. But if you've ever worked with list, all we're going to be doing with that is like extending from like a single city value into like a list of values, and I've got that commented out to where you can like easily find that yourself. Just remember that if you're wanting to sort of do this on your own, like if you want to find like the city code for whatever like region you want to sort of like reproduce this in, know that down in the history section in the almanac, I'm actually like using Beautiful Soup to like parse this out of the HTML and like grab the value. So like there's a tag that like Beautiful Soup uses, and it actually pulls the right values into our data set. So just know that this is like a non-obvious way of like how do you identify city codes from a Wunderground source. Okay. All right, so first thing, let's just go ahead and like step through. I haven't done any kind of importing like yet. Like this is just sort of like starting up like a blank sort of workflow that I'm working through the syntax. The first thing I'm doing is using like Unix style command line, which pwd is print working directory. That's pretty standard for a lot of languages. I'd like to list all the items in the directory, so ls gives me that. And what you see is there is sort of like the folder that I had here specifically on the project, where we've got two just Python documents. There are some CSVs that are available, and also like the IPython notebook that we're currently working through right now. The first script we're going to run, I've got this comment out right now because I want to actually like run this as a live demo. The Wunderground scraper is the first extension we're going to run. What's nice is I can stay in this notebook and I can just execute the cell or execute this Python file that's already within my directory just by running like a %run and then the name of the file itself. There's nice tab completion in Jupyter Notebooks as well. So like as you're going through and you're sort of finding things that are in the directory, if you just know sort of what the string starts with, there's nice tab completion that is really fast as well. So let's first off let's go see what this scraper, like how it works a little bit, and then like we'll actually run it and you'll feel the joy of web scraping. Okay, and just a note, this was written for Python 3 and above. It uses a URL lib reference. So if you're using like 2.7, let me know. I'm working on like a compatibility like code for this one itself. So if you're using 2.7, that's okay. Just find my email afterwards so I can pass you the better version. So using datetime, we're using URL lib request and URL open specifically to grab our weather data. I've got some commenting specifically that says, what we're doing. Remember the 4-letter name station that we're actually pulling from? That is another call out there, like if you forget about it. The date we're scraping is specifically like from January up until like March 2016. I'm controlling that through creating a couple objects for current date and end date. And then again, because we've got the date time imported into the script, that's all we're doing for hashing out dates. The URL that we're actually looking up is Wunderground's like .com, like publicly facing site, and we're passing through like some values specifically on the date. And here's a little while loop that passes those values through using a date stamp object. If you're wanting to do multiple city codes, I've got a list down at the bottom specifically that you can utilize on the script. So for instance, if I wanted to pull Indianapolis and Washington, D.C., Austin, Texas, Portland, and New York City, all places like I plan on visiting in the next, 4 or 5 months, like you can grab that, like their entire like year's worth of data and then follow along with the same plot, just for like the sake of time, because like it would probably take like at least 30 minutes to scrape all that information. I'm just gonna do a plot for Indianapolis. So that's what the py file looks like. So now we're back in a notebook. I'm actually gonna execute like that script. So we can run that just as is. What I want to show you is the directory that it's building. So in the project file, like you'll see there's an abbreviated KIND, which is like the call sign for Indianapolis. And we're actually doing scraping like specifically from that script, from Wunderground's data, and building like local HTML files in my directory. So I specified it from the beginning of January and all the way through March. And so this will take, I don't know, few more minutes to run. This is like the really geeky part, right? Where like we're collecting the data, and that's exciting. Does anybody have any questions so far on just like what they're seeing and like scraping, what libraries we're using, life in general? The big one that I think there's two that I'm using in this project, and most projects that I've been exposed to use are URL lib, which has been ported over to 3, but they kind of broke compatibility, so you have to kind of like find some alternate means. And then Beautiful Soup is one that I think most people are really familiar with, where you're actually parsing like known HTML. So this is a way that's done. So now I've got like the sample of files that I needed specifically off that scrape. What I can then do is use a parser, and the parser is the second script that I've written. It's Wunderground parser.py. We're going to execute that in just a moment right here in the notebook. But for the parsing function, you'll see that I'm using datetime URL lib again, and Beautiful Soup 4 specifically for the parsing function. Okay, so this is a library that I'm introducing on the second like run of the script. And what it does a lot of the same thing. It says, hey, I've got this directory of HTML files, and they're specifically in a folder, and their date ranges, like based on how they were saved, right, are all sort of like in a date order. So I need you to take the name of that HTML file and pass it in to a parsing record. And it looks for certain things, like so here we've got, we're calling Beautiful Soup on this HTML parser, and we're starting to like collect certain like values from that HTML. So where we were seeing historical like highs and lows of temperature, where we were seeing like recorded precipitation like for given data. All this is doing is looking at tags within Beautiful Soup. I don't want to go too far into web scraping, but like we're kind of already there, right? So all we're doing is like looking for tags into Beautiful Soup to like get that token value like from the HTML, and then just return that to like a much smaller unit in our array. And once those are collected, Python will continue to run through all of the available days that we've collected. So get that bit of information from a file, move on, move on, move on. And that's what the parser function specifically does for you. And again, if you've got multiple cities that you're wanting to do, like I've commented it out, but you can easily pass that into a list and parse everything. For our sake, we're just going to parse the one that we've got, which is just for Indianapolis. So the parser function specifically looks at all that HTML and brings it into like a local CSV file. And the CSV file I'm going to pick up from pandas and do some real basic kind of analysis with it. While that's loading, just kind of trust me that that's a kind of a populating CSV file. I've already like preloaded like a full year of Indianapolis like scraping, and so I'm gonna run now off of like more local disk and like show you data that I've already collected. You get the idea that the scraper works. You get the idea that the parser works. So what I've got is a static file now that we can actually step into and use what I would consider to be like more of just kind of a standard workflow when you're working with raw data. So I've got something that I can actually use now. It's in CSV, like, and that's a really nice format to work with. The first thing I'm going to do is import my libraries, and as you can see, like as you're running here, you've got kind of an interactive asterisk to let you know that all of these have loaded in. Once they're completed, like it shows like a number. Now that means any like corresponding like code that I execute has the pre-built packages loaded in, and now I can continue to work through like some of the libraries that you might be familiar with. This isn't restricted just to pandas and NumPy and whatnot. Like any libraries you have like within your distribution, like you can kind of call this up and like see your results inline as you go. One of the tricks I would recommend is using something called magics, which is you're throwing like a % sign in front of the code that you're executing, and this will give all our plots like within the same like document. So it becomes like sort of a code and plot like as you go through like a given data source. All right, so we've got our main stack. The first thing I'm going to do is I'm going to create an object, right? And the object that I'm creating is weather_data. What I'm doing is I'm calling on pandas as a pseudonym to read the CSV that I've got in the project directory. So in this case, this was like a full year of Indianapolis data .csv, and I'm parsing on the dates itself. So this grabs the data and it gives us a shape, which is 366 like records. That makes sense. Like that's like basically the full day, and then there's 13 columns specifically like attached in the data frame. For anybody that's coming like from a tabular sort of like arena, this is like this should kind of like feel like home, like where you're normally trying to get things into like arranged arrays, so you can actually work with you know, whether it's SAS data or R or some of the others. Calling dot shape on it gives you a tuple, which is the number of rows by the number of columns. I want to set an index on the date, and this is where Panda gets really like amazing, because it actually gives you a data frame. So where typically like R would be providing you sort of tabular analysis like in column and rows, with pandas and kind of doing this interactively, like you've actually got like all of the data like that I would normally like go in through another program to see like specifically how it's laid out in CSV. Because I've set the index specifically on the date, I've actually already ordered some of my values, and it kind of helps to like provide like an understanding of what we're doing. And I'm just passing in just one of the fields in the CSV specifically was a date, and I'm setting it as the index, and what you get is a nice return like inline on the notebook. All right, so that's great. It's like, so you've got like this tabular analysis, but like, what if you want to see things like graphically, because you've got a boss that like is really pushy and he wants to see things, and he doesn't understand all your tables and like all of these numbers. He wants to see pictures. So that's okay. There's plenty for that. And the first off being Matplotlib is I think a very foundational piece of software like for like the plotting community. A lot of packages have been developed since then that rely specifically, like they have a dependency on the Matplotlib library library, so it's one that's very rooted. There's a lot of other visualization libraries I can show you, like Bokeh and some of the others that have emerged like alongside the Jupyter Notebook, but just know that almost everyone that I've come across has been based on Matplotlib in some way, shape, or form. So it's just a good library to get to understand because other documentation is going to refer to it, and it's good to know that. So I've got some values that I need to sort of pick out of this data frame if I'm wanting to plot it. And so the next bit of code that I've got is actually pulling values out of the subset of data, and it's establishing a couple things. Like if we're going to plot it, we need an axis, and so I'm going to do that in time series using using date functions specifically to provide a day order of like how many days we're working with, and I want the values of like what was the record temperature that day, what was the minimum temperature, what was the average maximum, what was the average minimum, what was the actual for the specific date. So we've got like interaction in between, and what were the values specifically on those subsets. So this pulls all of the data in like immediately, but we want to plot this out. I've got a couple of layers of data that we're going to work through, and let me go ahead and give you the visual, and then what I'll do is kind of step back through the code to show you like what it's showing. Axis 1. So this is like all of the data from a year for like Indianapolis, where there's a few things. And let me throw a legend, like so we can actually like maybe make some sense of that. Arguments plot. Okay, we won't worry about it. How about title? There we go. That's a little nicer. Okay, so this is an example of how you can build a very like intense like time series plot where the red areas that you're seeing are sort of like the highs and lows on on like average data specifically like given through like the Wunderground scrape that we picked up. The blues are sort of like the tighter range of like here's what was like projected like for that day, like when you pull all the data points together, and then the gray is like sort of the actual like variations for that time of year. So if you're seeing like in March, for instance, like we're starting to get like seems like more colder periods like in January, and then all of a sudden like you've got highs and lows and everything in between. So this is just an example of like how you can just take data from the web, bring it in local source, and like work with it through a workflow. What's nice is like this file can then be handed off to other people to utilize, and you've got the same like procedures and steps of like how everything was built and formatted, and like where the data came from, and like what you did with it, like the entire step of the way. So. Are there any questions on like Jupyter Notebooks, like in general, like how this is utilized, or questions from the audience?
So that directory that we looked at that has all of these files ready to go, is that created when you run the notebook? Downloaded as a part of it, or
no, this is okay. So if you just head out to GitHub, like, and let me pull this URL up. That might be handy. So this is. So here's like a very geeky way of showing this. Like, so the terminal window that I like, whenever I initiated Jupyter like notebooks, what it did is it kind of created like a virtual, sort of environment for me to like work with data like interactively. And along the way, like the sort of as I worked through and saved my process, like there's like sort of a log file that Jupyter's keeping like inline. I'm working through the browser itself, so like I'm getting like interactive Python like in a Chrome browser, for instance. But like behind the scenes, like the way that's working specifically, is more familiar with what you might see with like sort of like Tornado or like some other like response server that's like actually sending files back and forth. So what I created was a repository that I've got here. If you head out to this domain, first off, what you can see is this project. If you're familiar like with using like command line git, then you can just copy this SSH handler and download it securely. If you're not familiar with git, it's okay. Like you can just hit download zip here, and this will just be like a zip that you can save into a specific folder. So so with the master file, I just got to download. There we go. So you can extract this into any place you'd like. Extract files, and then you can set a directory where you'd like things to go. But all we did within the notebook itself, like so for instance, this is actually like that same like file that's out here on GitHub where it's the PyData -webscrape -Wunderground. That's the same directory that I'm working in within a Jupyter notebook. So some of the callbacks that I was using, like when we were running the scraper functions, okay, the callback functions right here, like this Wunderground scraper, this Wunderground parser, those references are local to the directory that the notebook is running in, right? So you can see, like I've actually got a running kernel of Python running in the browser, and it's the name of the notebook that we've got there. Because I've got source files in that same directory, now I can, I can execute, create new directories within it. I can populate those with HTML files or images or whatever I'm getting from the web. And I've got sort of things warehoused where I need them, and your workflow kind of stays compartmentalized. Because I have things at a directory level, now I can zip that up, and I could send that through GitHub, and somebody's got the exact same kind of like shell of information like to work through with the analysis. Yeah.
It's not running in the browser, it's still running in the software server. What's the clusters feature?
Clusters is I don't know. I don't know. What I believe it runs is where you've got sort of like larger data warehouses, okay, where you've actually got repositories and that. So they published it as an HTML file, and so using something called Indy Viewer, which is like Notebook Viewer. And what it does is kind of take like a snapshot of like what we were doing, just kind of like with live data. It takes a snapshot of like what was your input, what was your output, and like what was your return. All the data there is there, all the code is there, like the results are there, and then you've got like actual like content that is like web friendly, like it's in a browser, right? And you can publish that, and that's specifically what the LIGO project did. They just didn't dress it up with as much like markdown as this document showed. Yeah. Yes. So there's a number of cloud like providers that. So the question was like if you had say like a notebook workflow that you wanted to host, but it needed to be secure, more or less. There's a number of cloud providers I know that are providing that you can specifically get sort of container type of environments, and you can place all the source files there.
There's a free one,
MyBender, is that it? Can you speak up just a little bit?
Yeah, I've been using Anaconda for machine learning class, and there's been always some challenges when I use it. So you can help me with that. One thing is every time if I'm in the middle of some work and if I close it, and I have to start from the beginning each cell and run it and go to that. I can't just stop and I complete it. Like say if you have 12 cells which you're working, and you finish at 6, and you say okay, let me take a break and close the browser and come back. I have to go again from 1 to 2.
Oh yeah. Okay, so well, like, all right. So the question was like he's executing code and then like kind of coming back and sort of things have like terminated. So if that's the case, like one, like if you have a lot of code that you're like having to reproduce, it's a good idea to sort of make that its own sort of like program, like as like a PY extension. So for instance, like one of the reasons why I wanted to demo this was that you know, there's certain functions that I don't want to have to run over and over. And so like in this exercise, we're grabbing data from the web and we're sort of like assigning values that are in an HTML table to, and sort of running jobs like in a smaller like contained unit, right? And we can go in and we can edit like what city day, and it's like very reusable, right? So because I've got that in a separate file, like that helps to sort of like, I guess, not have to reproduce a lot of the same work. Now, I will say, like, if you're stepping away from your machine after a while, like, you know, there's just certain probably local settings that you have that, like, certain applications are just gonna like turn off. All you have to do is come up to the kernel up at the top and like restart and either clear output or restart and run all, right? And that would essentially like refresh your browser, refresh your Python session, and like for anything that's already been executed or at least written, like you'll go ahead and like get back to where you were. So that would be my advice if you're kind of like having like sort of struggle with like the kernel like sort of like shutting down and then not running again. If just restart and run all, then it'll execute anything that like that it should execute. So. Yeah. So, and you have to be careful about that too, because like if you have something that you didn't want to run, like, you know, or if I had something that like, for instance, I comment out because I don't, you know, want to necessarily like execute it every time. It's only in certain situations, like, you know, where I've already gone in and amended a file, and now instead of Indy data, I want to pull, you know, something out of Portland or whatever. Then I can go edit my PY file and then come back in and execute it with the changes. So. This is just to kind of show reproducibility and like step by step. Like in a normal scripting procedure, like you wouldn't spend that much time on the line. Like you would have a block of code that executed a job for you, and like that would be specific to, you know, it did what it was supposed to do, and then you would move on to like what the next part of your process is. So just to make sure I understand your question, like if I wanted to go rerun this again, like one, it would throw an error because it would say, oh, you've already made that directory, because the directory that I built was specific to, you know, go grab this data, make a directory, and populate it. If we tried to run this again, we would get an error which says you've already got that file exists, like we've already done that. So.
If you close the browser but don't shut down Jupyter, the kernel running, you should be able to start right where you left off. If you shut down the kernel itself and restart the browser, then you start from the beginning.
And all it's storing is like the text, you know, within your cell, you know, so like, you know, objects aren't created until they're executed. So like, it's just text until like you actually execute the code. So, so as you, if you find yourself working with this at all, like, you know, the shift enter will actually execute the code that you're running, and you can really build applications in a very fast fashion, just because you can actually see your results in line as you go. And I know, and I think whenever I saw this for the first time, like actually in a browser setting, like it sped up like my interest in Python, and it sped up like my desire to learn more. So it was amazing to me to start working in Jupyter. For other people that are coming from languages and you don't have, you don't have anything like quite this interactive, like what's great is the Jupyter project was really taken, and I know I was like rubbing on Ruby kids earlier, so now this is me making up for it. What's great is you can actually like have different types of languages that you can run. See, I've got Ruby. I've got Ruby. Kids, I've got Ruby. You can have multiple notebooks that are specific to a given language, and you can execute the code in a really similar manner. What's nice about Continuum distribution is they have an R package that kind of comes with some pre-stacks in it. It gives you like a batteries included type of approach to things. But anyway, okay, so that was web scraping, Wunderground, and looking at Jupyter Notebooks. Any other questions before we move on? Two more questions. On the notebook?
Yes.
Okay.
One, say, once I save this, it's in the directory inside the file. But earlier I just had a standard IndyPy notebook in my directory. But recently the class required that I need to install Anaconda 3 version, and I installed that. So it took the earlier version and it reinstalled that. Now every time this IndyPy standard is not standard.
I'm guessing you're on Windows, by the way. I'm assuming. Yeah, that's all right. I'm on Windows too, so yeah.
So if I have to open the Jupyter notebook and then if I write simply if I double click on an IndyPy notebook file, it will not open.
And you have the Anaconda distribution?
Yes.
Okay, so it's very likely that you have like 2.7 and 3.5, so you might have two like versions of Python on the machine. Generally, Anaconda handles those pretty smoothly, but not every package that was built for 2.7 like will execute in 3. A lot of things have ported, but not everything. So, for instance, one of the libraries that we utilized, like in this exercise, was URL lib. That comes part of the standard library package, and there were some Unicode issues like between 2 and 3, like not, it's kind of at a high level. There's some Unicode issues that they tried to resolve with Python 3 that, for instance, Python 2.7 like didn't have. So if you had like a 2.7 installation and then you upgraded to 3, like there's some specific like literature I can like hand off like after the meeting specifically on kind of making your code compatible between Python 2 and Python 3, like the main library being 6, which is like an open source library to help convert like libraries from 2 over to 3. So I'll give that to you after the meeting if that's okay. What was your second question?
The second question was, earlier I just had a standard IndyPy. Just if I go to Windows and I can find a program standard IndyPy notebook and I click it, it will open. But now I don't have that anymore. I have to go to Jupyter Notebook and then do it. Is it they have changed it or is it something?
It changes a lot, yeah. So the one thing I would say, if you're kind of seeing this for the, or approaching it, the Jupyter project is like evolving like very, very aggressively. And its main focus has been specifically like on growing itself out to include other syntaxes. So like these kind of guys. C# is one, for instance, that like I'm really interested in getting like. Supportability like with these, just because like my team's a .NET team and like we use a lot of C# like for scripting, so I'm very interested in like supporting sort of the C# angle of it. But there's a lot of like evolution like with this as it's going. I think it's a very aggressive kind of goal to try to like incorporate something like this for as many programming languages as you can find useful. JavaScript, I know, is one that you can specifically embed as well, so that you can actually get interactive JavaScript at the same time. Which again, that for any developers, like that's a really useful feature to have. So, what I would say is keep up on like documentation specifically, and like if you're kind of coming into it for the first time, like I do, like I started with Python 2.7 and like 3 I think was not that hard of a switch. Like there's some things that have changed mainly, but I was lucky that I didn't have like a lot of code that was written in legacy Python 2 that requires a bunch of changing. So it just depends on, I think, where you were introduced to it between like 2 and 3. But if you can, I would recommend like staying in 3 as much as possible, just because a lot of the newer stuff that's coming out, for instance, like widgets and like a lot of the other things, like those are supported in Python 3, and it's a lot more fun to play with.
You want to touch on slideshow and Reveal.js?
I don't have any material on Reveal.js.
So when you're in the notebook, if you go to View and Cell Toolbar, and in that bottom one, slideshow, select everything. Creates all these little slide types towards the right, and if you're using this for coursework or for presentations, you've got a notebook and your boss likes meetings. You can click on one of those, select slide or sub-slide, and then it will render out a Reveal.js HTML. You can run that locally on your machine, and in terminal you can just do Jupyter NB convert, and then the name of your notebook, and then --2 slides, --post serve, and then that'll pop it up in your browser. And it's, I think a lot of us are familiar with Reveal.js.
Yeah.
Another, Brian and I were sitting next to some of the members of the team at Continuing Analytics. One of the things that they're working on is in preview right now is NP Present, which is another method for creating slides. I think that's in preview right now. They're expecting to go live.
Yeah. There's a lot of development around the project for sure. So, what you see tonight, like, won't be the same 3 months from now, just because like it's continuing to grow. But a lot of the core function of how it would be used, like, that's going to remain consistent, and even methods like we haven't even looked at today. So, so with that being said, here's a few recommends like for the topic itself. Like there's one coming out this summer I'm really excited about that Jake Vanderplas is. He's a PhD at the University of Washington, and he does amazing work like doing demos. I've seen him present like at conferences before, and he's writing one specifically for Python data science as a handbook. That's due out like in June. So if you're like an O'Reilly fan, or if you have like, I don't know, a birthday coming up and your mom asks you like what you want, you could say Python data science handbook, and like you can be like, thanks mom, like or not your mom, it could be somebody else that, if you have a birthday coming up. But anyways, it's high on my Amazon list, so I'm probably gonna like ask my wife for our anniversary or something. Something nerdy, right? Anyways, those are some recommends if you're kind of interested in the subject. Packet Publishing also has like some really great materials that I've found useful. We're gonna have some upcoming events like coming through the summer. So if you're interested in attending, we are going to be doing some workshop-based kind of like interaction on March 26th. It's on like a Saturday. Usually there's not a lot of like meetup groups doing stuff on Saturdays. I think it's like an amazing day to do meetups. And this will be at the College Avenue branch at the public library. So if you know where College Avenue is, it's very close to like mass transit on the Indigo, if you'd like. We're gonna have more of like an informal sort of a happy hour at Tomlinson Tap Room like a few days later in City Market. So you're very welcome to attend that. There won't be any like coding demonstration like on a day. That's just really kind of more of an excuse to like meet up with Python people and drink beer. And then in April and May, we've got at least one Saturday course or like workshop set up on April 23rd, Spades Park, and on May 14th, also Spades Park. That if you know where Mass Ave is, like that is a location sort of like on the north side around Mass Ave. It's a really kind of historical branch. They've got a nice meeting room space upstairs, so I'm pretty excited about that one. We're a very new meetup. I'm very interested in folks that are first off have an interest in the topic and are interested in presenting and kind of growing themselves at the same time. So if you'd like to kind of get involved and maybe you've got some cool code to show or you'd like to do a cool demo, definitely let me know and let's make the most out of it as possible.